Dear students, welcome to this class where we'll be taking up Mannich reaction. Now the history of this reaction, it dates back to 1912 when it was first reported by Mannich. This is an aldol type of a reaction, like the aldol reaction. And it's a three-component reaction whereby formaldehyde together with a primary or a secondary amine reacts with a compound which is having an alpha hydrogen, acidic hydrogen. So it can be carbonyl or any other compound and gives us a condensed product. What happens in this reaction is that in the first step there will be the nucleophilic addition of the amine to formaldehyde. The amine will react with formaldehyde to form a Schiff's base, and the entire process is activated with H positive. So we get the Schiff's base, the imine is now formed. Now this imine, as we know, the iminium ion, we can say, not the imine but the iminium ion has a positive charge. So this will act as the electrophile. This as the electrophile will tend to attack an electron-rich position. And how is that generated? That is generated by the carbonyl carbon or any other electron-pulling species which has an alpha hydrogen as the acidic proton. Because the acidic proton is removed, so automatically we'll get an electron pair. And this electron pair will be attacked upon by our Schiff's base or the iminium ion. And this leads to the formation of a condensed product, that is our beta amino. We will get a beta amino, beta with respect to the carbonyl or whatever electronegative group is there. So the beta amino compound is formed, condensed product. Now let's consider some points before discussing any further. The three things to be noted: that first of all, a primary or secondary amine or ammonia that is used. Secondly, a formaldehyde is activated with the amine to form the iminium ion. And thirdly, the alpha hydrogen, the acidic hydrogen, is used. So generated from what type of compounds? They may include carbonyl compounds with an alpha acidic hydrogen. They may include nitriles, acetylenes, aliphatic nitro compounds, and alpha alkyl pyridines, and so on. Now let's come to the application part. This is a very useful reaction, as are all the named reactions. That's why they are studied as a separate category and are important too for all the competitive exams due to their versatile nature, because they are employed for a number of synthesis reactions. So this too is used to prepare nucleotides, peptides, antibiotics, alkaloids, agrochemicals, polymers, catalysts, and also very important pharmaceutical drugs like the antidepressant fluoxetine and at the same time anti-inflammatory compounds like tramadol and talimetin. So let's see a little of this reaction, then we'll come to the mechanism. So here are two examples of the reaction, the three-component reaction. So this is the amine, here the secondary amine. This is our carbonyl. The carbonyl is, in the first case, there is another carbonyl, but this is formaldehyde. Remember, formaldehyde is always taken. The third component is the carbonyl or any other. We will see this is basically having an alpha hydrogen which is acidic. So this could also be like I mentioned earlier, acetylene or aliphatic nitro compounds or nitriles of this nature, which will all be, because they'll be electron pulling, so naturally this portion will be, therefore the hydrogen attached to the alpha position will become acidic. And see, now this is leading to this condensed product. The condensed product, which is with respect to this carbonyl, don't confuse it with this carbonyl, this is formaldehyde. Okay, this is a formaldehyde carbonyl. So with respect to this carbonyl, this is what? Beta, alpha, beta. So this is beta amino condensed product is formed. So in this second example here, I have shown it as such because see, this is oxygen. I have shown it in red. We can concisely write it as such, but we'll see the mechanism because with our classes we are expected to know the mechanism, and now at this level. So this is oxygen from where? The formaldehyde. This is hydrogen from where? The amine. That is why this hydrogen is necessary. Had it not been there, reaction would not have proceeded. That's why it can't proceed with tertiary amines. Now this and this, together with this third, that is formaldehyde and the amine, together with this carbonyl acidic hydrogen H2O. So minus H2O, and this will give rise to this beta amino carbonyl compound. Now the mechanism of this reaction, the mechanism proceeds how? This is formaldehyde activated by H positive. So H positive attacks this carbonyl oxygen to give OH, and now oxygen has got a positive charge. Once oxygen has got a positive charge, it becomes activated. Till here it was not. In order to activate it now. Now see, this has got a positive charge. So why it becomes activated? Because now it's unstable. As if things are stable, then they are not. But once it is unstable, it becomes reactive. And so it will react further so that this positive charge is removed from it, because this is electronegative. Positive charge on it won't be a stable position. So there comes the good neighbor, that is this amine. And this will donate its lone pair of electrons here to the carbonyl carbon. This is the carbonyl carbon, so that this double bond is now changed to a single bond. So positive charge from here is removed. So as a result of this, what will happen? This very cleverly has shifted the positive charge from oxygen towards nitrogen. Now from oxygen, because oxygen is in the 6th group, even more electronegative. Nitrogen is in the 5th. It is basic and less electronegative. So it is shifted to this nitrogen. So we get now the positive charge on nitrogen. Now how can this positive charge on nitrogen be removed? Because now if this H leaves, taking this positive charge as H positive, because continuously nitrogen will be pulling electrons from here because it is positive. So this bond will become weak and it will leave. That is another acidic hydrogen. This is the acidic hydrogen. So it will leave as H positive, and now we have this molecule NR2, H positive is lost, and over here CH2OH. Now what next? H positive, what does it do? Now this H positive will tend to attack or grab electrons from this OH. So what will be formed? H2O. And we know now oxygen has got a positive charge, but here it could not be removed. But here it can be. It is removed in the form of H positive, H2O from here when this H positive attack. So H2O leaves, and once it leaves this valency, this carbon falls short of this valency. So therefore electrons are supplied to it by again this good neighbor, that is the nitrogen. So the lone pair of electrons here, and finally what have we got? The iminium. Many a times it is shown in a short way, and that too is not wrong, but we should know the mechanism. That is shown in HCHO plus this R1R2N, that is secondary amine. So H here and O here, and another H minus H2O. So minus H2O, and we get another H from where? Because it's activated by this H positive. But we should show the mechanism as to how this H positive, it's simple, activates this formaldehyde, which is still now stable, it becomes unstable. And then, of course, once you know this first step, the reaction keeps moving forward by H plus gain and H plus elimination. So this will attack here. We will get this positive charge, again elimination of H positive, and we will get this OH, again addition of H positive, we will get H2O, and in nutshell, this H2O will leave, and we will get a positively charged iminium ion. Now this iminium ion, the Schiff's base, it is highly electrophilic because it's positively charged, so it will tend to attract electrons. And from where will they come? They will come from the enolization of the carbonyl compound. So the second step, this is the second step. So this carbonyl compound with the alpha hydrogen, which are acidic, will again be attacked by H positive so as to render it, this oxygen, make it what? Positive. And this will keep pulling electrons so that alpha hydrogens can be easily lost, these acidic hydrogens. So they are lost in the form of H positive. So we get this enol. Once enol has been formed, these pi electrons are now available for attack on nitrogen. So nitrogen, the positively charged electrophile, this attacks here and we get this product, that is NR2, forming the bond with this carbon. So carbon-nitrogen bond has been created, a new bond between this carbon and this nitrogen, the carbonyl carbon and this nitrogen. So we get this, and once we have got this, we know it can easily be converted into the carbonyl by elimination of this H positive, so that we get R3CO CH R4 CH2 and R1 R2. In other words, what have we got? We have got alpha beta. Beta amino carbonyl compound is the product which is formed as a result of this Mannich reaction. Now coming to the applicable part of this reaction, the Mannich reaction which we studied. How can it be utilized for our synthesis? So this is a very interesting example that we are doing here. See this, as soon as you see this carbonyl, formaldehyde, secondary amine, automatically 3-component reaction with H positive in the presence of, we will automatically be thinking of the Mannich reaction. So we will get a CH3CO and one H removed from here because this is acidic H positive. One H removed from here, O from here. So the condensed product that is formed will be CH3CO, CH2, then this is N, CH3 whole twice because this H has been removed. So what have we got? And from where have we got this other CH2? This is the CH2. This CH2 bridges these two, remember. This CH2 is bridging what? Our carbonyl, because it is the one which is taking part in the iminium ion formation. So CH3CO, CH2, CH2. And after that, this N, CH3 whole twice. And of course, when HCl will be present, it will form N positive. So, NH positive and Cl negative, the salt. So, now once we have got this beta amino carbonyl, beta alpha beta amino. So straight away we can write this, no problems, because we know the mechanism. Now let's see, we know that if this nitrogen is still having a lone pair, so it can be alkylated further. So if methyl iodide is added at this stage, what will happen? Further alkylation will take place, CH3 positive with this. So this will attack here, CH3 positive, the carbonium ion. So what will be formed? A quaternary ammonium salt. Now this quaternary ammonium salt is formed, and this quaternary ammonium salts, we know they are unstable. So as soon as they are heated, they will tend to give an alpha-beta elimination. So NCH3, this will leave because this will be pulling continuously electrons from this. This in turn will be pulling electrons from here. So this will become weak. So what will happen? This will leave hydrogen as H positive and this NCH3 from here. So we will be getting our double bond. Now what have we formed? We have formed this vinylic compound. So these are good for preparing such type of vinylic carbonyl compounds. So H from here, alpha beta. This beta H positive, alpha N with the 3. So trimethylamine, like NH3 ammonia, it's a neutral free molecule. So this will leave and we will get a vinylic ketone. Now this vinylic ketone, if to it this is added, this type of a compound is added, this carbonyl compound, what will happen? It will undergo, if you recollect, this is having once again our supply of electrons. Now this is, you see, Michael type. One is the Michael donor and the other is the Michael acceptor. So here the H is acidic, so it leaves from here, H positive, so we will get a carbene ion, and therefore this will enolize. We've studied the Michael reaction in great detail, and therefore this is what the alpha beta unsaturated ketone. This is a Michael acceptor, this is a Michael donor, and we get this Michael product. So this will be CH2, because this electron pair will be pulled towards carbonyl, so at positive at this end, so this will add to this carbene ion here, which has been generated by the Michael donor. Now CH2, this is the other CH, so CH, CO, CH3. And this CH will, of course, with H positive form CH2, like in the Michael reaction, which we have done earlier in detail. So once a Michael reaction, and we know now what have we generated further here. We have got the two entities for our aldol condensation. So this is carbon positive here attacked by this, and this will lead to, which we did earlier, Michael reaction together with aldol condensation will lead to elimination of OHH, H2O, and we will get this double bond unsaturated ketone over here. So cyclization has taken place. Prior to this, we did cyclization using just these two, Robinson, the Michael addition, and aldol condensation, which together is called as, these two steps together are called as Robinson annihilation. Now this is a step further where we are using for cyclization our Mannich reaction. So Mannich reaction can also be used for cyclization by together later reacting as a Michael acceptor, because this is what is formed from the Mannich reaction, this Michael acceptor, and this is the Michael donor. So the Michael reaction, this then will condense in aldol fashion to give us this alpha beta unsaturated compound, a level up to our Mannich reaction. The use of the Mannich reaction in the further synthesis of these class of compounds, very important. Now this reaction I'm just showing here so that you can see the importance of using secondary as compared to the primary amines or ammonia, because the more the number of acidic hydrogens we have, whether those acidic hydrogens are present on this in our amine, or whether they are present at this end, because if they are present over there, they will tend to keep reacting further as long as acidic hydrogen is there. And we don't want a multiplicity of products. We want one single product. Only then we will get a good yield. If 4 are formed, or 3 are formed, or 2 are formed, the yield of the product that we are desiring will decrease. Hence, it is advisable that depending upon the type of product we want, we take secondary. And here if we've taken primary, I'll just be illustrating, though you can make out yourself, because how this reaction will take place twice. Because see, once it has reacted and we have got our beta amino carbonyl CH3CO CH2, this CH2, then this CH2, and then NHR. Now still another hydrogen is there, so it can once again react with another carbonyl, another formaldehyde in the same way. This formaldehyde will react with it again to again form another iminium, and that iminium will react further with this our carbonyl. So we will get, until unless this, so the other hydrogen is removed, in short we can say. So we have CH3, CO, CH2, CH2N. This was from the prior first step of the reaction, and because we have got another acidic hydrogen, so this two will be replaced by this CH3, CO, CH2, CH2N. So we will get a di-substituted product. If we are desiring a mono-substituted only, we will end up with a di-substituted derivative or compound. So we must take also this into consideration. Now this is another interesting reaction. See, most of these reactions and variations which I am discussing, and I have discussed earlier also in the name reaction series, are the ones which are often asked in modified ways or at times the same type of questions in your competitive NET GATE exams. So as long as you are clear with the concept, you'll be able to solve them easily, and some of them have been solved for you itself. So see, this was what we started off, the carbonyl, formaldehyde, and this secondary amine. So again, condensed to give us by Mannich reaction this CH2 NR2. So alpha beta amino carbonyl. So beta amino carbonyl was formed. Now on alkylation, as we did earlier, we'll get a what? We'll get a quaternary ammonium salt. And when this is reacted with NaOH in the presence of a base, what will happen? This will tend to pull off electrons from itself. So this will leave as a neutral molecule, trialkylamine. And when this leaves from here, the beta position H positive is pulled with the help of OH. So we will get this type of a double bond. That is, a vinyl group has been formed. Now this vinyl group, if it is acted upon by certain, because this requires electrons. So because these electrons, again alpha beta unsaturated, as you can see. So this will be pulled here and this will be pulled here. So with the result, what will happen? So what can happen is, because this can easily, we can have now with a compound which is rich in electrons such as the cyano, we can have a 1,2 or a 1,4 addition. Both can take place. 1,2 means this adds to this, O negative, H positive, and C positive, Cn negative. So this will be 1,2. Now this is, because this has been pulled here, so this is, the electron pair is moved from here to here. So this carbon will get positive charge. So the other option will be 1, 2, 3, 4, the 1,4 addition. And as we studied earlier in our Michael type of reactions, that the 1,4 addition or the Michael, see, so this is again combination. So in those Michael reactions, what happens? Because this is soft as compared, so it will attack a soft site rather than attacking the carbonyl carbon. This will tend to attack our in a 1,4 fashion. So this will be the product that will be formed. So a 1,4 addition. Moreover, if this is hydrolyzed, then this will give us a COH. So we can see the use of this reaction. Now here's a small question for you. After doing all this, because we've done quite some variations of this reaction, Mannich reaction, as well as how it can be applied for the synthesis of rings, how it can be applied for the synthesis of unsaturated carbonyls, and how it can further be stepped up by using a variation in the form of quaternary ammonium salts. And then nucleophilic addition taking place to give us different types of products. So the question is, if you've now followed it properly, this will be easy for you. I would like you to reply to this in the comment section as to what is formed. What happens when indole reacts with formaldehyde and dimethylamine, followed by alkylation, so it is clear, and reaction by sodium cyanide with sodium cyanide and hydrolysis. It is further hydrolyzed. So it is quite a simple reaction. I'm sure all of you will be able to manage doing it. So good day to all of you.